Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. And as promised guys, this is the part 2 video on the trigonometry ratios video that I did for you guys, where we went through just the basics that you guys need to be able to understand to help you solve your trig ratio questions, right? So in this video tutorial guys, I went through your trig ratios when you're given just a regular or a right angle triangle, right? I explained to you guys what happens or how are your trig ratios defined on your Cartesian plane, right? And I also explained why we are taught that in the first quadrant all the functions, all the trig ratios are positive. Why are we told that in the second quadrant only the sign is positive? Also explain that why are we taught that in the third quadrant only the tan function is positive, and in the fourth quadrant only the cos is positive, right? So I went through all of that with you, right? I also showed you guys how you basically get that in the first quadrant, that is the 90 minus the theta quadrant. I explained that to you in the video tutorial. I explained that in the second quadrant, that is the 180 minus theta quadrant, or the 90 plus theta quadrant. Also explained that in the third quadrant, this is the 180 plus theta quadrant, or the 270 minus the theta quadrant, right? I also explained that in the fourth quadrant, right, this is the 360 minus theta quadrant, or the 270 plus theta quadrant. And I gave these reasons because I said that in the first quadrant, right, you've got values that are less than 90 or equal to 90, but greater than 0 or equal to 0, right? In the second quadrant, right, values that are in the second quadrant are values that are greater than 90 or equal to 90, or less than 180 or equal to 180, right? In the third quadrant, I explained that you've got values or angles that are greater than 180 or equal to 180, right? Or less than 270 or equal to 270. And lastly, I mentioned that in the third quadrant, we've got values that are equal to 270 or greater than 270, right? Or less than 360 or equal to 360, right? So I went through all those technicalities. I explained every single thing in detail, guys. Please make sure that you watch that video tutorial if you do not know what I'm talking about. But if you do, then you are more than ready to go through the examples, because on today's video we will be going through the examples for trig ratios, right? So this helps you in analyzing your questions that you guys will be given in your tests or exams that want you to basically use trig ratios as well as an aid of a diagram to answer your questions, right? So like I mentioned, we're going to be going through example 1 together, example 2 together, example 3 together, as well as example 4. This is great practice for the next lessons that I'm going to be uploading for you guys, right? There's compound angles, and with compound angles, guys, you are going to be asked to use trig ratios to solve compound angle questions, right? You will also be asked to also use special angles to solve compound angle questions, right? And also just basic application of compound angle formulas, right? So this is why I'm actually doing this video tutorial, because I want to show you how you work with ratios. Because if you understand that, then you're able to build on your knowledge to answer your compound angle questions. All right, so guys, without any further ado, enough with the chit chat. Let's get started with what you guys came here for, and that is today's video tutorial. Example 1. If 5 sine of x is equal to 3 and x plus y is equal to 90 degrees, calculate without a calculator the value of cos of y, this is our 10.1, and tan of x plus tan of y, this is our 10.2. All right, so what is the first thing that we need to do if we're given a question like this, right? You need to obviously look at the information that is given to you, right? And with the information that is given to us, we are told that 5 sine of x is equal to 3. Okay, what do we know when you're working with trig ratios, right? We know that when you're working with trig ratios, you can use SOHCAHTOA to help us in defining our trig ratios, right? So now, considering the fact that we're given 5 sine of x, which is equal to 3, right? we want to be able to basically know where our angle X is situated on our right angle triangle, so that we are able to define the other trig ratios that haven't been given to us, right? Because as you can see here, we are asked to calculate the cos of y, and we are also asked to calculate tan of x as well as tan of y, right? So that means that we need to basically use our right angle triangle and use the knowledge that we have when it comes to defining trig ratios to help us find how your cos of y is going to be defined and how your tan of x as well as your tan of y is also going to be defined. Let's start off by isolating sine of x. So you're given 5 sine of x, which is equal to 3. Okay, and to isolate sine of x, or to have sine of x on its own on the left hand side, we can just divide by 5, right? So you have sine of x is equal to 3 over 5. Okay, what do we know about sine of an angle, right? To define the sine of an angle, we know that sine of an angle is equal to your opposite side over your hypotenuse, right? So the 3 is the side that is opposite our angle, right? And the 5 is the side that is our hypotenuse. So if we make use of a right angle triangle to help us define our trig ratios, how would that look? Okay, so that would be our right angle triangle. And we know that the angle x, right? The opposite side to our angle x is 3, and the hypotenuse for our triangle is 5, right? So if I would decided to put my angle x there, okay, the side that is opposite my angle x is 3, and the hypotenuse, we know that we've got a 90-degree angle here, so our hypotenuse will be 5, right? Because we saw here that sine of x is defined as 3 over 5, meaning that 3 is the side that is opposite our angle and 5 is our hypotenuse, right? So then from here, what do we see, guys? We see that we have a side that is missing, right? And the side that is missing is the side that is adjacent to our angle x, right? And what do we know? How can we calculate that side? We can calculate that side by using the theorem of Pythagoras, right? So by using the theorem of Pythagoras, we can calculate that unknown side, right? So if I were to name this triangle ABC, okay, we can calculate side BC by using the theorem of Pythagoras. Alright, so like I mentioned, we can just use the theorem of Pythagoras to calculate our side BC, right? Or our adjacent side to our angle, right? So what does the theorem of Pythagoras say? It says that the hypotenuse squared is equal to AB squared plus BC squared. Right? What is our AC squared? So it's 5 squared is equal to, what is our AB? 3 squared plus BC squared, right? So we just solve for our BC by isolating it, right? So we're going to have 5 squared minus 3 squared is equal to BC squared. And if you square root both the sides, right, you'll be able to see that your BC is equal to 5 squared is equal to 25 minus 9, and that is square root of 16 is equal to BC. So in other words, our side BC is equal to 4. So now that we found BC, right, we already have the adjacent side to our angle, right? So now we've got the opposite side to our angle x, we've got the hypotenuse, and we also have the adjacent side to our angle x, right? So how do we move forward from this? How can we now use this information that we've just calculated, right, to calculate the value of cos of y as well as tan of x plus tan of y? We are given additional information here. We're told that x plus y is equal to 90 degrees, right? But then we were able to define our trig ratio sine in terms of x. So how will we be able to define our trig ratios in terms of y? So this is where the additional information comes in handy, right? We already know that the side that is opposite our x is 3, the side that is adjacent to our x is 4, and the hypotenuse is 5, right? But we don't know what that angle there is equal to, right? So we need to basically calculate what this angle there is, right, and see if it can help us make sense of what our cos y is equal to, right? So how can we calculate that angle there? Okay, so we know when you're working with a right angle triangle, the sum of the sides, the sum of all the angles in a right angle triangle equal to 180, right? So if I add this 90-degree angle here, and if I add this angle x, and if I add this unknown angle, I'm supposed to get 180 degrees, right? So how can we calculate the value of our own unknown angle, right? So we know that if you add all the angles of this triangle, angle A plus angle B plus angle C, that should give us 180 degrees, right? We already know, we don't know what our angle A is, right? We know that your angle B is equal to 90 degrees, right? Plus, we know that the angle C is equal to x, right? So how do we calculate your angle A, right? We can calculate it by obviously isolating it or having it on its own on the left-hand side. So we'll be left with 180 degrees minus 90 minus x, right? And if you solve this, 180 minus 90 is 90 degrees minus x. So angle A is equal to 90 minus x, right? 90 minus x, that is our angle A. But how is that going to help us in terms of the additional information that is given, right? We are told that x plus y is equal to 90 degrees. We want to be able to define cos in terms of the angle y, right? So using this equation, we need to basically isolate the y, right? So if you isolate the y, it's going to be y is equal to 90 degrees minus x, right? And what do we see here, right? We see that we've got 90 minus x here, and we've got y, which is equal to 90 minus x there, right? So that tells us that the angle A is equal to y. And because now we know that that angle A is equal to y, we are most definitely now able to calculate cos of y as well as tan of y, right? Because we have the two angles in our triangle. We've got an angle that is x, we've got another angle that is y, and we are now able to define our trig ratios in terms of the angle x and the angle y, right? So we can start with question 10.1, okay, which asks us to calculate the value of cos of y, right? So what is our cos of y? We look at our angle y there, we think of SOHCAHTOA over your hypotenuse side. So what is the side that is adjacent to our angle y? The side that is adjacent to your angle y is 3. So cos of y is equal to your adjacent side over your hypotenuse, right? So what is your adjacent side? Like I mentioned, it is the side 3, because that is the side that is next to your angle y. And what is your hypotenuse? Your hypotenuse is 5. Okay, so cos of y is equal to 3 over 5. Okay, let's have a look at 10.2. Okay, and I mentioned that to help us remember how we're supposed to define our trig ratios, we can use SOHCAHTOA, right? And we see that to define the tan of an angle, we take the opposite side over your adjacent side with respect to that angle, right? So we're gonna start off by finding what tan of x is, right? So I'm gonna do my answer there. What is tan of x? You look at your angle x, right? What is the side that is opposite our x? It is 3, right? And what is the side that is adjacent to our angle x? It is 4. Okay, so tan of x is equal to your opposite side, like I mentioned, which is the 3 over your adjacent, which is your 4, plus tan of y. You look at your angle y, that is your angle y. What is the side that is opposite our angle y? It is 4 over what is the adjacent side to our angle Y? It is 3. Another thing that I want you guys to take note of, if you're not working on your Cartesian plane and you're just using a right angle triangle to help you define your ratios, please use SOHCAHTOA, right? SOHCAHTOA. But the minute you work on your Cartesian plane, then you can choose between using this one or SOHCAHTOA to help you define your trig ratios. Let's go to the next question. Example 2. If tan of x is equal to 12, right, and theta is an element, right, between the interval of 90 degrees to 360, determine without using a calculator but using a suitable sketch the value of sine theta plus cos theta. Right, so guys, the first thing that we need to do, we need to basically isolate the tan of theta, or have tan of theta on its own on the right hand side, right? Which quadrant are we working in? So let us have a look at the quadrants that we are working in. Okay, we're told that we are working in the interval of 90 degrees to 360, right? So let's see, which quadrants are we in? From 90 degrees, right? So it's from here to 360 degrees. So we're working in the second quadrant, in the third quadrant, and in the fourth quadrant, right? And then what do we see? So number one, we've basically written out our tan of theta in terms of ratios, right? Number two, right, we've basically looked at what is the restrictions, right, in terms of which quadrants we are working in, and we know that we're either in the second, third, or fourth quadrant. And the third thing that you need to look at is the sign of your tan theta that you've already worked out here, right? So this tan of theta is positive, okay? Tan of theta is equal to positive 12 over 5. Right? So that means that your tan of theta needs to be positive. What do we know? All students take care. Where is your tan function positive? Your tan function is positive in the third quadrant. Okay, so that is our diagram. How would you now get your theta? So your theta is from the positive x-axis, moves in a anti-clockwise direction to there, right? So that is our angle theta. Okay, and then what do we notice when we are working in the third quadrant? We notice that your x is negative and your y is also negative. Okay, so what does that tell us? It tells us that for this trig ratio that we've just obtained here, right, we remember that you can use your shave your area, cos x ray, tan your exterior, right, to help us find our trig ratios, right? So because we've got tan of theta, that means that your y is equal to 12 and your x is equal to 5, right? But because we are working in the third quadrant, that tells us that now if we had to find the value of our sine of theta is y over r, right? So we would have to substitute a y value that is negative, right? So your y value is actually negative 12 and your x value is actually negative 5, right? So then when we want to find the value of the sine theta plus cos theta in terms of our trig, defining our trig ratios, we need to take into consideration that we are in our third quadrant, and in the third quadrant, right, your x is negative and your y is negative, and we need to take that into account when we are finding the value of the sine plus cos of theta. Okay, I showed you guys that we are working in the third quadrant. Okay, and in your third quadrant, your y is negative and your x is negative, right? I also told you guys that we can use shave your rear, cos x ray, tan your exterior, right? So sine of theta is equal to your y over r plus your cos of theta is equal to your x over r. We found that your tan of theta is equal to 12 over 5. And I also told you guys, because we are in the third quadrant, that means that your y is actually equal to a negative 12. And your x is actually equal to a negative 5. So how do we get your r? Right? We can simply get your r by using your Pythagoras theorem. Your Pythagoras theorem states that your r squared is equal to x squared plus y squared. Okay, and your x squared is minus 5 all squared plus your y squared is minus 12 all squared, right, to get us your r. So your r is equal to 13. Okay, so that is the value of our r, right? So from here we can just continue and substitute. What is our y? Our y is negative 12. What is our r? Your r is 13 plus what is our x? Your x is negative 5. And what is your r? Your r is 13. Okay, we can just simply, guys, punch that into, obviously they said without the use of a calculator. Okay, so it's minus 12 minus 5 is minus 17 over 13. Okay, so that is our answer, guys. Okay, I'm gonna just revise what we did. So what we did with this question, guys, right, we were told that if 5 tan of theta is equal to 12, right, and we are given the interval that we're working in, right, so we're working in the quadrant that is equal to and greater than 90 all the way to 360, right? So we're working in the second, third, and fourth quadrant, right? Determine without using a calculator but using a suitable sketch the value of sine theta plus cos theta. So the first thing that I told you guys that you need to do is you need to isolate this tan of theta, right? Right, so that you're able to get it in terms of its trig ratios. And we found that tan of theta is equal to 12 over 5. Right, so because we found that it's 12 over 5, how does that help us with anything? Right, the 12 is the y, because we know that tan of theta is y over x, or opposite over your adjacent, right? So we found that your y is equal to 12 and we found that your x is equal to 5. Okay, but we're not done. We are now need to decide which quadrant are we working in. Are we working in the second quadrant? Are we working in the third quadrant? Or are we working in the fourth quadrant, right? So we can see initially with this question, our tan is positive. So where is tan positive? Tan is positive in the third quadrant, right? So we were dealing in the third quadrant. And what happens in the third quadrant? Your x is negative and your y is negative, right? So then we need to include that your y is negative 12 and your x is negative 12, right? That was not included there, because if you say negative 12 over negative 5, it becomes a positive 12. Hence your tan is positive, right? But then you need to write this down like this, because when you're trying to find the ratio of the sine and the cos in terms of theta, right, you need to include that the y is negative 12. You need to include that the x is negative 5, because we are working in the third quadrant, right? So from there, guys, we know that sine of theta is y over r. We know that cos of theta is x over r, right? And then we simply found the value of r by using the Pythagoras theorem, because we know that we're working with a right angled triangle that is on our Cartesian plane, right? We find that your r is equal to 13, right? We know that sine of theta is y over r, right? So your y is negative 12, because we're in the third quadrant, and in your third quadrant your y is negative, right? And your r is 13, plus Your x is -5 because we're in the third quadrant, and your x is negative in this quadrant, over 13, and we simply just add it, and you have -12 minus 5, which is -17 over 3. Okay guys, let's go on to the next question. Example 3, if you're told that sine of A is equal to 3 over 5, and this tells us about which quadrants we are working in, right? So it's 90. A is greater than, but not equal to 90, but less than and not equal to 270. So that helps in telling us which quadrant do we need to focus on. Okay, determine by means of a sketch the value of cos A plus sine A all over 1 minus 1 over 3 times tan of A. Right, so because we know that sine of A is equal to 3 over 5, what do we know? Shave your rear, cos X ray, tan your exterior. Alright, so because we've got sine of A, we know that this 3 is the Y and this 5 is the R. Okay, so we can just simply use the theorem of Pythagoras to calculate the X value. Alright, but before we apply the theorem of Pythagoras, we need to see which quadrant are we working in. Which quadrant do we need to focus on? Right, so here we see that sine is positive, right? What do we know? All students take care. All students take care. Okay, we are told that we're working in a quadrant that is greater than 90 but less than 270. So which quadrant is that? Greater than 90, so that's there, but less than 270, so that's there, right? So those are the two quadrants that we are working on, right? We can see that the sign here is positive. Sine of A is positive 3 over 5. Where is sine positive, right? Sine is positive where? In your third quadrant. Okay, so that is our angle theta, measured from the positive x-axis going all the way to your second quadrant. So that is our angle A, right? Not theta. Okay, that is our angle A. Okay, so then from here, what is your y, guys? We already know that your y is 3. And what is your x? Your x is in the second quadrant, and in the second quadrant, what is going on with our x? Our x is a negative. Okay, we use the theorem of Pythagoras to help us calculate the value of our x. We know that r squared is equal to x squared plus y squared. We already have r, which is 5 squared. We want x squared, and we already have y squared, which is 3 squared. All right, you make x the subject of the formula. And when you make x the subject of the formula, you have 5 squared minus 3 squared, which is equal to x. So from here, we've got your value of your r, right? You've got your value of your x, taking into consideration the sine, and we also have the value of our y. So now we're going to take the value of your x, y, and your r, and we're going to substitute it into this formula to calculate the value that is required. So let's just fix the calculation error that I did here. Your x is actually equal to 4 and not 5. Okay, the square root of 5 squared minus 3 squared, you'll get a 4, right? So your x is actually equal to -4. Okay, so x is equal to -4. Okay, that's the only mistake we made there. Okay, so x is -4 all over 5 plus your y is equal to 3 over 5 all over 1 minus 1 minus 1 over 3 multiplied by what is your y is 3 over what is your x is negative 4. Okay, we simplify this further. I'm just going to do it here. Minus 4 plus 3 minus 4 plus 3 is minus 1 over 5, right, all over, okay, 1 minus 1 over 3 multiplied by negative 3 over 4 is equal to negative 1 over 4. Okay, so it's going to be negative 1 over 5 all over 1 plus 1 over 4, right? Let's deal with the denominator. It's 1 plus 1 over 4, which is equal to 5 over 4, which is going to be negative 1 over 5 over 5 over 4, making your final answer equal to negative 4 over 25. Okay, so cos A plus sine A all over 1 minus 1 over 3 tan A is equal to negative 4 over 25. Okay, and let us look at the last example, guys. Okay, if tan of alpha is equal to negative 3 over 4, okay, and we are given that alpha is an element of 0 degrees to 180 degrees, right? And we're also told that 13 cos of beta minus 12 is equal to 0, and beta is an element of 180 to 360. Calculate the value of sine alpha, sine beta without using a calculator. Okay, so guys, we're going to start off with this section. We're given that tan of alpha is equal to negative 3 over 4. Okay, so we know that shave your rear, cos x-ray, tan your exterior. Okay, so because we're given negative 3 over 4, we know that, okay, this tan of alpha is equal to negative 3 over 4, right? We know that tan of an angle is y over x. So that is y and that is x. But we need to decide, where does this negative apply? All right, so that's why we go to the Cartesian plane. Okay, and we're given restrictions. We are told that we're working from 0 to 180, right? So if this is your 0, this is 90 degrees, this is 180 degrees, this is 270 degrees, this is 360 degrees, right? And you are focusing on this quadrant and that quadrant because we're working from 0 to 180 degrees, right? What other information are we also given, right? We can see here that your tan is negative. Okay, so where is our tan negative? We know that all students take care, right? So since we're working in the first two quadrants and we are told that tan is negative, right? Tan is positive here, but tan is negative there, right? So we are working in the second quadrant, right? Okay, so your angle theta is measured from the positive x-axis to there. That is our angle alpha, not theta. That is our angle alpha, right? And we are told that y is equal to 3, but we need to decide, is the y a negative or positive? We'll see. Your y is equal to 3 and your x is equal to 4. So now do we see where this negative is applying? The negative is applying to the 4, right? Because on your second quadrant, your x values are negative, right? So the x is a negative 4 and the y is a positive 3. Okay, so we need to basically use the theorem of Pythagoras to find your value r. So your value r squared is equal to x squared plus y squared, right? What is your x squared? Your x squared is negative 4 all squared. Plus, what is your y squared? Y squared is 3 all squared, right? Therefore, your r is equal to negative 4 all squared plus 3 all squared. So it's 5. Okay, we put that on our diagram. Okay, so now we are able to find what the sine of alpha is, right? So sine of alpha, right, is equal to shave your rear cos x-ray tan your exterior. So sine of alpha is y over your r, right? So for your alpha angle, what was your y? Your y is 3. And what was your r? Your r is 5. Okay. Now let us deal with the beta part, right? Previous. Cool. So now we need to find what sine of beta is. So that means that now we need to look at what we're given here, right? So we're given 13 cos of beta minus 12 is equal to 0, right? First thing that I told you guys is that we need to isolate this cos of beta, right? So the 12 is going to go to the other side. It's going to be positive 12, right? And you're going to be left with 13 cos of beta. Therefore, cos of beta is equal to 12 over 13. Okay? So what do we know? Cos of an angle is equal to x over r, right? So the 12 is the x and the r is the 13. However, we were given information about which quadrant we'll be working in, right? So we're working in the quadrant from 180 degrees to 360, right? Okay, from 180 degrees to 360. So those are the two quadrants that we're going to be working in, right? But hey, what else do we see here? We see that our cos beta is positive, right? So where is cos beta or cos ratio positive, right? Our cos ratio is positive. All students take care in the fourth quadrant, right? Because we're told to focus particularly on this, on the second and the third quadrant, because we're told that from 180 to 360, right? And focusing on those two quadrants, we know that cos is positive in the fourth quadrant. Okay, so how would we measure our angle beta? Our angle beta would be measured from the positive x-axis to our line there, and that is our angle beta, right? Okay, we have our triangle there. What is our x? Our x is 12. What is our r? Our r is 13. Okay, what is missing? We are missing the y value. How do we get the y value? We use the theorem of Pythagoras, which is r squared, which is equal to x squared plus y squared. Okay, we've got r squared, we've got x squared, we need y squared. So r squared minus x squared is equal to y squared. Okay, I'm going to just continue and do it there. Okay, so the square root of r squared minus x squared is equal to y, right? Our r is 13 all squared minus your x is 12 all squared, and you find that your y value is equal to 5. Okay, Okay, so now here's the trick. Okay, is this y value positive 5 or is it negative 5, right? So since we are working in this fourth quadrant, we know that our y values are negative, right? So that tells us that the y value is going to be negative. And then from there, we're going to simply substitute sine of beta, okay, which is y over r, right? What was our y? Our y is negative 5. What is our r? Our r is 13. Therefore, sine of beta is equal to negative 5 over 13. Therefore, sine of alpha multiplied by sine of beta is equal to sine of alpha, we found it to be 3 over 5 multiplied by sine of beta, which is equal to negative 5 over 13. Okay, so the final answer, okay, so that can be simplified to negative 3 over 13. In our next video tutorial, guys, we are going to be going through compound angles, right? How we can use these trig ratios that we've learned to solve compound angle questions, right? I'll also be taking you through just how to use basic application of compound angle formulas, right? Just taking the formula as it is, substituting values to get your answers. And I'll also be taking you through how we can use spatial angles to solve compound angle questions. That is our next tutorial, guys. Please make sure that you are subscribed to the channel, right? Because I am going to be making sure that I teach you guys each and every topic in a straightforward and easy way. Please, guys, make sure that you are subscribed to the channel, and also please make sure that you give my videos a thumbs up so that we help the channel grow and help it reach to reach more learners that want to better their mathematics, or learners that just want to or learners that are even struggling with mathematics, guys. Okay, we are on the road to reaching 1,000 subscribers, guys. Please help me reach that goal of 1,000 subscribers and even beyond, right? Please help me reach that goal by subscribing to the channel. And guys, that is it for today's lesson. I hope that you enjoyed it, and I hope you see where I was coming from with that first lesson where we went through trigonometry, trig ratios, where I explained what was going on in the Cartesian plane, right? And I hope that information that I taught you guys in that lesson helped in the application of the examples that we were doing today. Okay, guys, so that is it for today's video tutorial, and I'll see you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.